Hello and welcome to the Algebra 1 video for Section 6. This is titled Analyzing Graphs, and what we want to do today is we want to use the graph of a function to determine the key aspects using interval notation where applicable. Okay, so taking a look at this, this is a picture of a flat piece of paper, and if we were to cut out the corners of that paper and fold up the sides, we would get a rectangular prism, okay? And so, what we have here is we have, Lorena is making a storage container from a piece of cardwood with side lengths of x plus 3 and x minus 1. She is going to cut 2 inches from each corner to be folded up for storage. The equation that represents the volume of the container is x minus 1, x minus 5, and then 2. And this should be changed to x minus 5. Okay, let me do that real quick. This should be x minus 5. So, you have this function here for volume, okay? And the thing of it is that you have this function here and it says, what does the input represent? And that's our x value. So what does x represent? Now, the output value is v of x, okay, which is your y value. And that represents the volume of the box, okay? That part's the easy part, okay, is that, once you figure out what, these values for x are, and you cut out 2 inches off of each side, then you get to, determine what the volume of the box is. Okay, so but x is really just your length and width. Okay, and so, but we use these, because you can change the length and the width, and that affects the volume of the box. And so what we're going to do is we're going to kind of look at, some graphs to help us, kind of determine, how different things affect other things. So, this example specifically, how does the length and width affect the volume of the box? So as we take a look at some of our graphs and certain things that we need to know, to analyze a function's graph, the one thing that we want to look at are for x-intercepts and y-intercepts. Okay, x-intercept is the location where the graph crosses the x-axis. Okay, and then the y-intercept is the location where the graph crosses the y-axis, okay? And so as we take a look over here, we just have this generic graph here, and I want to point out that, we're looking for the location where it crosses the x-axis, okay? These are x-intercepts, all right? So that's x-intercepts. And then we want to look and see where does the graph cross the y-axis, and those are called y-intercepts. Okay, so typically on a function you're only going to have one y-intercept, but you could have multiple x-intercepts. Okay, and so let's take a look over here. And what this has, okay, you have this graph. Okay, consider the graph that represents the volume of Lorena's container. Okay, and this is from the problem before where you had that function from the previous page where you had v of x is equal to x minus 1 times x minus 5 all times 2. Okay, and so on this graph, remember your x represents, x allows us to get the length and width, okay, and then the y represents the volume. So on this, it says, what do the intercepts mean in terms of context? So what does this mean? So when x is 1 or when x is 5, okay, you have these points here where 1, 0, and 5, 0. Now, the thing that I notice here is that, when you have a value of x that is 1, you get a y value of 0, okay? And remember, y is the volume. So the intercepts is when the volume is 0. Okay, now the other question that's being asked is, what is the appropriate domain for the given function? And, what I want to show you guys is that, if you look at this graph, you should notice that there is, I have y values here between 0 and 1, and then beyond 5, okay? And I have y values at all those other points, but the difference is that right here, this tells me that I have a negative volume, which just doesn't really make any sense, okay? So what we can say is that our domain, would go from 0 is less than x is less than 1. Okay, so x could be between 0 and 1 to actually give us a volume. And then, okay, and we could say that x is greater than 5. So kind of a unique problem, but let's go ahead and let's take a look at another one. And all this is asking me is says use the graphing tool to determine the intercepts. And so what I want to do is first locate my x-intercept, which is right here. So I'll do x in red, and I'll plot that point here. And that's that point, you could say that x equals 3, okay, for the x-intercept, or you could say that you have the point 3, 0, okay. The y-intercept down here is right here. Okay, I'm going to do that one in blue. And the y-intercept is where it crosses the y-axis. And that looks like it's a value of y equals 12, okay? Or you could say the point 0, I'm sorry, not 12, negative 12. Negative 12. So let's write y equals negative 12. Okay, that would give us a value. That would give us our y-intercept. All right, let's take a look at another one. And then it says, which statement is true about this given function? So we have that same function, and we want to see what it says here. And it says f of x is greater than 0 over that interval. Now, when it says f of x is greater, remember f of x means a y value. Means a y value. Okay? And so what this is saying, it says, f of x, the y values are greater than 0, meaning the y values are positive between negative infinity and 3, okay? And that's not true, okay? The y values between negative infinity and 3 are actually negative, okay? So this is false, okay? This is false, all right? It says that the y values are positive over the interval from negative infinity to positive infinity. And that's false too, because they're negative here, the y values are negative, and then they change to positive here, okay? So, you have both positive and negative. They're not positive over the whole thing. And then it says here, so this is false. And then on this one, it says the y value, f of x, is less than 0 over the interval from negative infinity to 3, okay? And that is true, okay? That's true because the y values are negative over that interval from 0 to negative 3. So this part right here is your domain, okay? This is your domain. And it's asking about what's going on with the y values over those given x values, okay? And so what I know is that the y values are negative. These y values are negative. Okay, and then I know that these y values here are positive. So these are positive, these are negative. okay? And we go from, negative infinity to positive 3, okay? So that's true. The other one that says that the f of x is less than 0 over the interval from negative infinity to positive infinity, that is false because we know that the y values are positive here and negative here, okay? All right, let's look at another one. Now, I kind of want to switch gears here and take a look at a graph and identify a few things, on a graph, and something that we need to be able to locate on a graph and read from a graph. So, the first things that I want you to see here is that, when we read a graph from left to right. Okay, so I want to write that down. So when we read a graph, we read from left to right, okay? And what I want to talk about here is, a couple different things, and one of them is called increasing and decreasing. And so increasing, okay, and I'm going to use green here. Okay, when we increase, okay, increasing means that the graph goes up. So the graph goes up. Okay, and then when we have this other thing called decreasing, the graph goes down. Okay, we could talk about how the y values get larger and how the y values get smaller. And we'll talk about that in the next one. But that's the idea, is that, when you look at a graph, when you read a graph from going left to right, what are the y values doing? So the y values are going up here. You hit a maximum point, and then we're going to call that a local max. And then, then we go back down, and then we call that decreasing, okay? And so if we go from increasing to decreasing, okay, that's going to give us a local max, okay, a local max, and that's the peak of a mountain, okay. Local maximum, we call that the just the largest y value over an interval, okay. So you just have this maximum y value here, okay. Also, similarly, if you went from increasing to decreasing, if you go from, decreasing to increasing, then you get what's called a local minimum. Okay? And all I'm asking you guys to do is to identify these from a graph. Okay? And that's the idea. All right? And then the other thing we want to do is we want to talk about something that we call end behavior. So we're going to kind of look at the same graph or a similar graph. And what we want to look at and identify from a graph is what's happening as x gets really big or x gets really small. So when we talk about end behavior, I ask the question, what are the y values doing? What are the y values doing when x approaches positive infinity and when x approaches negative infinity, okay? So again, what are the y values doing as x gets really big and as x gets really small? So as x gets really, really big, okay, as x approaches positive infinity, what are the y values doing? Okay, the y values are approaching here, are approaching positive infinity, okay? So we can write that down over here. We can say that as x approaches, okay, and I use that arrow to say approaches, x approaches positive infinity, then y approaches positive infinity as well, okay? And then, as x approaches negative infinity, okay, what are the y values doing? Are the y values going up or are they going down? And in this case, they're going down. They're going to negative infinity. So we can then say as x approaches negative infinity, okay, we can then say that the y values are approaching negative infinity as well, okay? And then kind of just depends, okay? But this is how we write that, okay? As x goes to infinity, what are the y values doing, okay? And we call that end behavior, all right? All right, and so then, you know, what we want to do is let's take a look at this graph over here, and it says, let's analyze the graph to determine the intervals of decreasing and increasing function values. So I'm gonna come back here. I'm gonna change that color. Increasing was green, and decreasing was purple. Okay, and so I'm just gonna go over here, and I'm gonna kind of think about what I had. And as we read the graph, increasing means that the graph goes up. Okay, decreasing means that the graph goes down. Okay, but we got to read it from left to right. So I'm just gonna go over here, and I'm gonna say, all right, well, we were increasing all the way up to this point here, okay? We change to decreasing, all right? And then we switch back and we go back to increasing. The graph goes up. So where the graph is green is where it's going up. Where the graph is purple is where it was going down, okay? And so what we want to do is we want to say, okay, well, over what intervals are we increasing, okay? And when it says determine the intervals, these are x values, okay? So where are we increasing at? So what I'm thinking, and I'm going to use red to show my x value, you know, where are we increasing? So where is the graph green, okay? And so what I'm going to do is go, and I'm going to use the shading tool for this. I think that kind of helps. You know, we were increasing, you know, I'm thinking over the interval between negative infinity, you know, negative infinity and negative 1 is where we're increasing, okay? Over those x values, from negative infinity to negative 1, the y values on this graph were going up, okay? And so I'm going to write that. I'm going to say that we were increasing from negative infinity to negative 1, okay? And, okay, because there's another one that I notice, is that we were increasing also from what looks to be about 1.5, okay, 1.5 to positive infinity, okay? So this is from about, you know, I'd say, you know, 1.5 to positive infinity, okay? So here's about 1.5 and positive infinity. Okay, over those x values, and that's just all I'm looking at. I'm just looking at these x values, okay? Where was I going? Where's the graph going up? Okay, and then the other one is where's the graph going down? Okay, and so that's the space in between. Okay, and those x values go from negative 1 to positive 1.5. So I'm going to write that we go from negative 1 to positive 1.5. Okay, and when I use these parentheses, we call this interval notation, and we'll kind of talk more about that. But you know, you can use interval notation or you can use you know, inequality notation. It's kind of up to you guys. So, okay, let's take another look at, you know, what's going on this one. It says, use the graph to determine the true statement about the end behavior of the function. So here's what I'm going to do. Okay, I'm going to come on this graph and I'm going to say, all right, as x goes to infinity, okay, as x gets big, as x approaches infinity, what are the y values approaching? What are they going to? And it looks like they're going to positive infinity, okay? And then as x goes to negative infinity, okay, what are those y values doing? Those y values are also going to positive infinity, okay? So it's going up in both directions, all right? So it says this, let's read this. As x values go to positive infinity, the function values go to negative infinity. No, and that's not the case, okay? They were going to positive infinity. So this is false, okay? Okay, as the x values go to positive infinity, the function values go to positive infinity. And that's true, okay? As x gets big, the y values get big. So that's true, okay? So let me write that here. Okay, the next one says as the x values go to negative infinity, the function values, the y values, go to negative infinity, and that is false, okay? They're going to positive infinity, Okay, so then on the last one is x values go to positive infinity, the function values are equal to 0. And that's also false. The y values, the function values are getting bigger. So this is also false. Okay, so that second one was true. All right, let's take a look at the next one. And it says, use the graph to determine the local minimum and local maximum values for the function. Okay, so what I want to do is talk about the increasing and decreasing. I'm going to highlight the graph where it's decreasing, okay, and then highlight where we're increasing, okay, and then we're decreasing here, and then we're increasing. So when it changes from increasing to decreasing and vice versa, that's where we have a maximum, okay, or a minimum. So just to clarify, all right, if we're looking for a local minimum, okay, that's when our graph goes from decreasing to increasing, okay? And that occurs at this point right here and this point right here, okay? You can see that the graph goes from decreasing to increasing, and so at that point we have a minimum. Same thing over here. So let's write those points down, okay? This occurs at the point -5, comma, -95, and the point 2, comma, -95, all right? And then let's talk about our local maximum. That's where we go from increasing to decreasing, okay? And that occurs right here, where we go from increasing to decreasing, and that occurs at this point right here. And let's write that point down as -1.5, comma, 55.06, okay? And so, and that's the thing, guys, a local minimum or local maximum, these are large and small y values over a small interval, okay, just where it changes from decreasing to increasing, okay? And, you look at this maximum value, this is not the largest y value that's on the graph, okay? The graph will go up to positive infinity on both sides, but this is where we change from increasing and then go to decreasing again, okay, which gives us a max, okay? So I think that might be it. Let me check and see if there's anything on the next page. And boy, oh boy, is there another graph, okay? So let's take a look at here. And let's answer this one question, okay? And it says, use the graphing tool to find the local minimum and the local maximum for the given function, okay? So, okay, if it's asking for minimums and maximums, then let's highlight where the graph is increasing and where it's decreasing, okay? So we're decreasing here, okay? And then we are decreasing here, okay? And then we are increasing from there to there, and we are increasing here to here, okay? So then, all right, so and that just kind of helps me identify my points, okay? And let's just remember that, if we go from decreasing to increasing, that gives us a minimum, okay? If we go from increasing to decreasing, then that gives us a maximum, okay? So then let's take a look at some of these points where that occurs, all right? And so then it says this, over the interval from -3 to -1, so let me write those down, from -3 to -1, okay, what is the local minimum, all right? And let me change my color to red. -3 to -1, okay, what is the minimum? And we're just looking over that small little interval, and our minimum is at the point 0, -2, okay? And that's where it changes from decreasing to increasing. So we have the point -2, 0. Okay, that is our local min. Okay, over the interval from -1 to 0, okay, what is the local maximum? So we're looking at, this interval now from -1 to 0, okay, looking over that one. And that looks to me like we've got a value, oh gosh, I'm just going to say -0.75, comma 5, okay, is that point right there, okay, which is this point right here. All right, and then over the interval from 0 to 3, okay, let me show that from 0 to 3, what's our local minimum, okay? And our local minimum is all the way down here, okay? And that's going to be the point, and let's just say that's the point 2, let's say that's 2 comma, negative 32. Okay, that would be fair and reasonable. So that's the idea. So just being able to read a graph, knowing where you're increasing, decreasing, where you have minimums and maximums. So there is some vocab involved. We do need to know those words. I encourage you to write those down. So hope you enjoyed this, and we'll see you in a bit. Thanks. Bye.